In this video, we're going to continue with what we learned in the video notes for Standard 6, where we're using our calculator to be able to look at functions, figure out where they're increasing and decreasing, find out their maximum and minimum values, where are they concave up, where are they concave down, all that good stuff. But we'll do it for a couple more sort of challenging functions here. Just to get a little bit of practice with ones that kind of have some interesting things about them. So we'll go to our y equals menu, and in example 1, we'll go ahead and type this out here. So we have 1/9 t to the 5th, so I'm just going to use x to the 5th, minus 4x cubed plus 9x squared. Whoops. This is a really easy thing to do on accident, so pay attention, make sure you don't do what I just did. So you have to, when you're up in that exponent, make sure you hit over before you start typing the next term. So 9t squared minus 3. All right. And we'll start off by looking at just the standard window. I'm not sure if mine's set there yet, so I'm going to go to Zoom, Standard, which is number 6. All right, and that's what I see right there. All right, so I can basically see what's going on here, right? I've got this maximum somewhere way up there, a minimum here, a local maximum there, and a local minimum here. So let's find the 3 easier ones. And what I understand here is it's helpful to retain the order that you write them in. So we'll say x is approximately, so we'll go from, smallest to largest. But this is the one that I'm going to have to do a little bit of work to actually find. So let's start with the biggest one over here. So we know that what we're going to do is go second calc, and we'll find a minimum value. Now, of course, this problem didn't say anything specific about finding local max or local minimum values. However, we know that that's what we have to do in order to find where it's increasing and decreasing, because that's going to be where it transitions. All right, so we'll go with the nearest hundredth. So we'll go 3.52. All right. And we'll do that maximum right there. Get to the left, get to the right somewhere, press enter again. So about 1.75. And I suppose what's not a terrible idea is, as we go here, we'll just say this is a max, right? This is a min. And we can find this one. Kind of looks like it's 0. I wouldn't be surprised if it is. All right, and this is one where we got to be kind of more clever than the calculator. So this number right here is 9.0116 e negative 7. That means times 10 to the negative 7. So remember what that means is that the decimal gets moved to the left 7 places. So it's actually 0.00000090116, okay? So what's happening here is that the answer really is 0, but based on the algorithms that are used to to find this minimum, it doesn't always hit it exactly. So even though that's what it spit out, I'm going to say 0. All right, now the last thing here is I know that I need to find a maximum that's up here, but it's really quite far up there. And so while I could try to do this without adjusting my window, it's going to be hard because of how steep this is. So what I'm going to do is I'm going to adjust my window so that I can see up there pretty well. and they're not getting, these two parts of the graph aren't getting close together very quickly. So I think I'm going to have to increase my y values by quite a lot. So all I really need to do is mess with my y values. So I'm going to go to y max and I'm going to type in 1,000. Not sure if that'll work well. We'll see. So now I'm going to hit graph. And that did. So of course I can barely see that there are maxes and mins over here where I found them before, but I can now clearly see this leftmost maximum. So calc. So I just need to get somewhere to the left and somewhere to the right. So it looks like negative 5.27. So this one was a max and this one was a min. All right. All right, so now let's go back to our, well, let's stay here to go ahead and start the process of finding increasing and decreasing. Okay. So for increasing, we want to write down intervals where that's happening. So the first thing that's happening is we're increasing, right? So we're definitely, the graph is getting bigger as I go from left to right. So you always say as the x values are moving to left to right, are the y's getting smaller or larger? And they're getting larger everywhere back here, all up until they hit this spot here, and then the y values start getting smaller, right? So we're increasing from negative infinity up to that first maximum x value. So that would be negative 5.27. And I use parentheses for negative 5.27 because if you're at the top of the hill, you're neither increasing nor decreasing, right? So you don't want to include that in the interval. All right, and then now we're decreasing until we hit the next one, right? And we know that that next one is 0. All right, so we would say it's decreasing, excuse me, from negative 5.27 up to 0. Now for the rest of this, I kind of want to see a little bit better. So I'm going to go back to zoom standard so I get that original view. All right, so now I'm at 0. I'm increasing again until I hit that next maximum. So I'm going to glue this together, take the union of 0 to 1.75. And then I'm decreasing from 1.75 up to that last minimum. And then I'm increasing again from 3.52 onward. So we get 3 different intervals where we're increasing and 2 different ones where we are decreasing. All right, so that took care of this part, right? But what about concave up, concave down? All right, so concave up and concave down, right? That's not something we're going to find in our calculator. That's something we're just going to have to kind of eyeball. All right, so remember that they transition at what we call these inflection points. Ooh, boy, I ran out of room. I'm writing too big. All right, let me change colors so that they don't run together so much. All right, so inflection points. So where are those happening at? So that's where it looks like it's transitioning from being concave up to concave down. And again, I'm going to start over here on the right side because I can see it pretty plainly right now. So we're going to have, looks like 3 inflection points. So starting on the rightmost one, I think it's happening right about there. Okay, so let's see, where do I think, we don't have to get too precise about this. I'm going to call that 2.8. Okay, 2.8. So that's what I'm going to call it. Again, we're just eyeballing these. This one here, I'm just going to call that 1. Okay. Now this other one, I need to go back to my old view if I want to make a judgment about where it switches from being concave up to concave down. So let's go to Window and go back to having an X maximum of 1,000. All right, so I'm going to say it's right about there. Okay, and where's that? Let's call that, let's see, so it's going to be, yeah, I'm going to say right about there. I'm going to say that's about -3. Okay, you know, again, we're just eyeballing here, -3. Okay, so now what I can do is I can list concave down, and then over here, well, I think I need to go right here, concave up, running into example 2. All right, so I'm concave down, right, from -infinity all the way up to that -3. Okay, and then, well, let's go ahead and change our view back to standard view. So I'm concave up from -3 all the way up until this estimate that I made, which was at 1. And then I'm concave down again from 1 to this 2.8 number. And then from 2.8 on, I can go from there. All right, so again, the concave up and concave down, you're going to have different answers. You know, so like if you're checking your work based on what I wrote down on a particular problem, you know, we might be off by a little bit. So as long as you're in the neighborhood, you're doing fine. All right, one other example here. This one won't take us nearly as long, but it's an interesting one. So let's see here if I can kind of clean this up a little bit. So we're going to kind of highlight that in green and try to differentiate it from all the stuff we just wrote down. Hopefully you didn't write as big as I did in your notes. Okay, so we'll go to our y equals menu over here, get rid of that other function, and go ahead and type in x times the square root of 6 minus x. All right, and then we're going to graph that in the standard window, and we get this. Okay, so increasing and decreasing is going to be pretty simple here because there's only one maximum, right? So let's start with that. So we have a maximum at x is approximately, and we'll go ahead and find that maximum. All right, and here's another one where it's 4.000004, but I think it's 4, right? And what we're probably just getting here is the fact that the algorithm's just not getting it perfect, okay? So we can say that we are increasing from -infinity up to 4, and we are decreasing from 4 up to, now we got to be careful here. Might be tempting just to say infinity, right? But it kind of looks like the graph is stopping, okay? But where is it stopping? Well, here's where it's important to go back to our algebraic skills, right? What do we know? We know that we're not allowed to take square roots of negative numbers. So that means 6 minus x must be greater than or equal to 0. So this is the domain, right? X is less than or equal to 6 is the domain of this function. So that means things have to stop at 6, right? You can't be decreasing if the graph doesn't exist at that particular spot. So that's where we gotta, you can't just go totally on autopilot with working with your calculator. You definitely need to think about what you know algebraically as well. All right, and then finally here, as far as concave up and concave down, well, look at this. It's concave down everywhere, right? So we would say concave down from negative infinity, but only up until the end of the domain of the graph. It's concave down.